Hello everyone, I'm Jiang Ruiyao. This slide introduces the crystal structure of zinc oxide, its structure and optical characterization, and the relationship between characterization results. Zinc oxide is a wide bandgap semiconductor used in optoelectronic devices, ultraviolet detectors, gas sensors, photocharacterizers, and other fields. Different experimental techniques will be used to demonstrate the structure, effects, and optical properties of zinc oxide. Okay, first I will talk about the fundamental crystal structure of zinc oxide. Zinc oxide is a binary compound semiconductor composed of zinc and oxygen. The most stable and common crystal phase of zinc oxide is the latticized structure. And for the crystal structure consists of each zinc ion and 4 oxygen ions in tetrahydroxide ordination, forming a stable zinc-oxygen bonds network. And it's a hexagonal crystal system with space group P63 and C. The lattice constants of vertex zinc oxide are approximately A is equal to 3.25A and C equal to 5.28. About this, we can see the picture is show the data. And crystal structure is belongs to hexagonal Bravey lattice. And the non-central symmetric structure gives zinc oxide special properties, like high electricity or optical activities. And zinc oxide tetrahydroxide ordination leads to anisotropy along to the zinc acid and affecting the electronic and optical properties of zinc oxide. And then is the phase and structure characterization XRD. Analysis of the crystal structure always using X-ray diffraction. We always say XRD. Besides the photo, we can know the XRD pattern shows characteristics diffraction peaks on the 100, 002, 101, and other crystal planets. The peak position correlated with standard crystal zinc oxide reference data, indicating a pervasive phase without other impurity phase. And then the relatively broad diffraction peaks indicated that the zinc oxide crystal size is in the nanometer range. And then we can see the Strategy formula D equal to K lambda over 2 beta cosine theta. It estimates the average zinc oxide grain size to be approximately tens of nanometers. And then is morphology and lattice TEM. What is the TEM? The TEM is transmission electron microscopy, provides information on the morphology and crystal quantities of zinc oxide. TEM images reveal zinc oxide nanometer structures. We can see the photos. They have nano rows, nano wires, and nano particles, and they determined by the synthesis methods. And about the nanostructure, the nanostructure have high surface area or volume radius, making them suitable for sensing and photocatalysis. And Perfect growth orientation results in good crystallizity. And for the imaging, we can know high relationship and images reveal clear lattice ranges with an interplanar spacing of approximately 0.287 nanometers is equal to vectorized inner side 100 planets. We can see the picture D. The D single side 100 is equal to 0.287 nanometers. And other like picture C, it always show the 002 equal to 0.344 nanometers. And then I will talk about the latest vibrations and defects, Raman spectroscopies. The Raman spectroscopy for detecting lattice vibrations and crystal quantities. The picture A, B, C, D always show the one thing, that is the mean zinc oxide peaks are approximately 100 centimeters at E2 is low and approximately 437 centimeters at E2 high. Before that, we can know the sharp and high intensity E2 high peaks indicating good lattice quantities and low defect densities. And then from the picture, we can find the A1LO or E1LO in the 517 to 585 centimeters range is associated with oxygen vacancies and lattice defects. All of that, these enhanced defects indicating increased concentration, affecting the optical properties of zinc oxide. And then is electronic band structure UVS absorption. The UV is absorption spectroscopy reflects the electronic band structure of zinc oxide. You can see the first picture is the zinc oxide in 3 different years. One is hydrothermal, and then is chemical based desorption, and then is electrochemical desorption. We can see the zinc oxide in different years have different absorptions. First is 375 nanometers, and then is 385 nanometers, and the last is 384 nanometers. Before that, we know the zinc oxide is a direct bandgap wide bandgap semiconductor, so it exhibits a distinct absorption rim at approximately 317 nanometers in its UVS absorption spectrum. And the second picture shows the EG of the UVS. First, we can see the EG equal to 3.32 eV, and then is 3.22 eV, and the last is 3.23 eV. About this, we know its optical band gap is approximately 3 to 4 eV. In summaries, we know the quantity confinement effects or changes in band structure. Alter particle size or dropping shifts the absorption EG, thus adjusting the band gap to meet different application requirements. And then is optical emission and defects. Photoluminescence. For the photoluminescence, we always say is PL results. Reducting, recombination process, and defect dates. We can see the pictures. The zinc oxide have 2 main emission characteristics. The first characteristic is near band it ultraviolet emission at 380 nanometers, like excision recombinations. And from this, we know the strong near-band Ig emission indicates high crystallized and efficient excitation recombination. Our second characteristic is the 500 to 550 nanometers from band green emission, like oxygen vacancies and surface defect states. About the Raman spectroscopy and these photoluminescences, we know PR result correctly with Raman spectroscopy is better crystal quantity leads to stronger ultraviolet emission and higher defect concentration enhance green emission. Okay, for the last is about correlation, conclusion, and application of zinc oxide. Before that, we know the XRD verifies the research crystal first and grain size. The TM reveals the nanostructure, morphology, and lattice orientation. The Raman spectroscopy assesses lattice quantities and defect concentration. And then the UVS absorption spectroscopy reflects the electronic band structure. And the last PL spectroscopy correlates defects and optical emission behaviors. About that, we know the characteristics. Techno verify the structure and properties of zinc oxide. And by the combining XRD, TM, Raman spectroscopy, UVS spectroscopy, and PL result, we can understand the structure, defects, properties, relationship of zinc oxide. And the zinc oxide crystal structure, defects, and optical properties are correlated. Okay, in summary, by controlling the synthesis of annealing conditions, defect density and optical response of zinc oxide can be adjusted, ultimately making it suitable for UV emitting device, gas sensors, photocatalysis, and optoelectronics device. Okay, all of that. Thank you for your listen.